Now we have a compound inequality. And so compound inequalities are a little different. So if we have it, so we have two different ways we can have a compound inequality. We can have an and, or we can have an or, okay? So and is the same as intersection. If you understand intersection, you'll understand and. And or is the same as union. So if you understand union, you'll understand these. If you don't, well, what does the intersection mean? The intersection means what, for math, I would say what values, or you can say data, whatever you like, is in common to both sets of data. So basically, well, actually, I don't even need this, I already said it. So basically, what values or data is in common to both sets? Think about an intersection that you drive through with your car, right? So if this is one road and this is another road, this is the intersection. It's where they meet. This part here that I colored in, notice it's in common to both streets, right? So that's the intersection. What else can I say about intersection? I can give you an example using just a set of numbers. Let's say I have 1, 2, 4, 5. So let's call this set A, and we'll call set B 2, 5, 9, 10. Okay, so now we want to know what is the intersection. So I could say, what is we say it a little different in set notation. This would be A intersect B, which is the same as saying A and B. So what value is in common to both A and B? Okay, and that would be the set 2, because 2 is in common to both, and 5, because 5 is in common to both. And that's really it. There's no other numbers that are in both sets. So when we start solving inequalities, we're going to have two separate graphs on a number line. And what we want to do is see where they overlap, what they have in common. Okay. The other thing we have is or, which is the same as union. And this is really the same as saying what values are in either set. Or we could say we combine all values, right? So we're going to combine everything together, even if they don't overlap, it doesn't really matter, but it's the combination of every value that's either in one set or the other set. Okay. For example, like if I said, are you and your significant other coming to my party? I'm not saying is one of you coming. I say I'm actually saying both of you, right? I want to know if both of you are coming. So that I say, and are John and Mary coming to the party? So they may say no, just John's coming, or no, just Mary's coming. That would be a false. They're not both coming. But if I say union, and I would say it differently. I would say something like, is John or Mary is John or Mary coming to the party? Well, if I said, if John shows up, then the answer is yes. If Mary shows up, the answer is yes. If they both show up, that's fine as well, right? But if neither show up, then it's false. So with or, it's a combination, like it doesn't matter if both things happen, just one or the other. So if I use the same example where I have A equals 1, 2, 4, 5, and I have B equals 2, 5, 9, 10. For this set, which is a little different than the inequality, but I just want to explain union and intersection. When I say the union, I want all the values, right? So I have a 1 that's from A. I have a 2 that are in A and B. I don't have a 3 anywhere, but I do have a 4. I have a 5. I have a 9, and I have a 10. So notice I've actually combined all the values from either one of the two sets, and that gives me the union, which is the same as OR. So now we have an and, right? So one of the most important parts here is for the compounding is that's an and, which means that we have an intersection. Okay. So what do we do? Well, we have to solve each inequality separately. So I start with 2x minus 7 is less than minus 1. I'll add 7 to both sides, and I get 2x is less than 6. And then I divide both sides by 2. 2's cancel, and I get x is less than 3. So that's my first inequality, right? X is less than 3. And let's do the same thing for 3x plus 5 is greater than or equal to 3. So I'm going to subtract 5 from both sides, which gives me 3x is greater than negative 2. Divide both sides by 3. Notice I'm dividing by a positive number, even though the number I get is negative. So I don't flip anything because I'm dividing by a positive number. So here I get x is greater than or equal to negative 2/3. So these are my two solutions. And what I want to do, first thing I want to do, the easiest way to solve this is to put it on a number line to begin with. So I'm going to start here. Let's say this is 0, 1, 2, 3. And I'll go negative 1 and negative 2. Negative 2/3 is really between 0 and negative 1. So I've got enough here. So first thing I'm going to do is I'm going to graph x is less than 3. So less than 3 means I don't include 3. And I'm going to write it above the number line so we can see what we're talking about. Okay, so this is x is less than 3. And then I have, let's do it in, well, I guess we'll do it in green. X is greater than or equal to negative 2/3. And negative 2/3, let's say this is negative 2/3 right there. And since it's greater than or equal, I put a closed circle, and this is going to go on forever in this direction, right? This is x is greater than or equal to negative 2/3. Okay, so now let me get a new slide here. Oh, that's not what I meant to do. All right, so let's go back here. Get a new slide. And I will copy this number line over to the other. It's not gonna work. Okay, so here is the number line that I created from my two solutions. And remember, we're looking for and. So we're looking for and, which is the same as intersection, right? So what we're looking for now, here, I'll use the highlighter. We're looking for what they have in common. So what we're looking for is basically, here is where the green line starts. Even though the red line goes more to the left, it doesn't matter because you have to have the red and green line to make an intersection. So we're going to start at -2/3. And again, we can see that we have both of these lines all the way up to here, right? And that's where it stops. So I know now my intersection, so it's stopping here. So my intersection, or what these two lines have in common, is from -2/3 till we get to 3. Let's see, did they say interval notation? Okay. So our smallest number in our solution, this is our solution. Our smallest number is -2/3. And the biggest number is 3 for the intersection. And I can include -2/3 because -2/3 is in common to both of those lines. Even the red line, even though it doesn't have a dot, there is a dot there. There is a number there that's included. But when we get to 3, the green line definitely includes 3, but notice the red line doesn't. So for them to be in common, I would have to say we're not including 3. So that's the solution graph, and that's the interval. This is interval notation. All right, let's do another one. This time we have OR. So what do we do when we have an OR? Again, we still solve them each separately. So we have 1 minus 3x is greater than or equal to 7. I'll subtract 1 from both sides, and I get -3x is greater than or equal to 6. Now I'm dividing both sides by a negative, right? Negative. There's a negative number, right? So that means we have to flip our inequality. So first thing I'll do is I'll just rewrite it this way. So I have x, and now because I divide by negative, I'm flipping my inequality, and I have 6 divided by -3, which is -2. So that's the solution. Actually, I'm going to write it down here. So x is less than -2. I just want to give myself some space here. Okay. So that's my first solution. My second solution is I have 3x plus 4 is greater than 7. I subtract 4 from both sides. I get 3x is greater than 3, right? These cancel. And divide both sides by 3. And I get x is greater than 1. So these are my two solutions. And we're going to again write this in interval notation. So let's copy this. Actually, I can remember this. I think I can remember it. Let's put a new slide in here. And I have x is less than or equal to -2 and greater. So x is less than or equal to -2 and x is greater than 1. Is that right? X is greater than 1, x is less than or equal to -2. Okay, so again, we're going to start by putting it on our number line. And let's see, we have negative, so here's 0, here's 1, 2, 3, and so on. -1, -2, -3, and so on. Okay, so Actually, here, I'll do it like this. The red line is going to be x is less than or equal to -2. So I have a closed circle because it can equal -2, and it's all values less than that, which means it goes to the left. And then I have another one, I have or, right? X is greater than 1. So I have an open circle, and these are all values that are greater than 1. Now we want the union. If I wanted the intersection, hopefully everybody can see from this, from graphing it, that there is no intersection. The intersection would be no solution because they never overlap, right? There's no numbers that are in common to both x is less than or equal to -2 or x is greater than 1. There's nothing in common. So the intersection here, or if I had an and, it would be no solution. Hopefully that makes sense. But there is a solution here because or means I include every value in one inequality or the other inequality. And to put it into interval notation, I always start at the smallest value. So the smallest value is -infinity. And I'm coming up this line right here, right? So I'm starting at -infinity. And I'm going to come all the way up to -2. And because it's included, I put a square bracket. And then I have nothing between -2 and 1. I have no values. So I'll leave it for a second. And then I'm going to start at 1, but we can see that 1 is not included. And I'm going to go all the way to +infinity, which always has a parentheses. And so here's my two intervals that are my solutions. Hopefully you can see how it translates directly to the intervals that I've put there from the number line. And or, remember I said is union, so we put a union sign between that. That means I take all the values from one of those intervals and I unite it with all the values from the other interval, and that gives me the final solution. So this is the final solution in interval notation. Okay. All right, so now we have, again, an and. So let's see what happens. I don't know what's going to happen beforehand. This is not the one we did before, right? Doesn't look, no, it's a little different. Okay, yeah, it's a little different. Okay, so we'll start here, and again, I'll add 1 to both sides. So I get 3x is less than -6. And then I divide both sides by 3. Again, I'm dividing by a positive number. Even though it's going to be negative on the right, it doesn't matter. I'm dividing by a positive number. So this is going to be x. The sign does not flip. So this is x is less than -2. And here, let's subtract 1 from both sides, which gives me 4x is greater than 8. I'm dividing by a positive 4. And I get x is greater than 2. And in between them, I have an and. Now with ands, we have an intersection, right? So if we want to graph this, which I really recommend you all do, so you can kind of see what exactly is happening. And okay, so again, I'll do this green one. This x is less than -2 in red. So I start at -2. I do not include -2. And I go all the way to -infinity. And let's see, I guess I'll do that one. I'll do that one in purple. So I'll do this one in purple. And this is x is greater than 2. Which means I start here, and these are all values greater than 2. And it's an and, so I'm looking for the intersection or what they have in common. So I can see they don't overlap anywhere, do they? Which means this has no solution. This would be like if I said, is John or Mary coming to the party and neither one show up? There's no solution. It did not happen. Okay. So there's nothing in common. So that's all we can do with that. All right. So now we have some word problems. So let's see what we have. Suppose you rented a forklift to move a pallet with 70 blocks stacked on it. Okay. Okay. So we can kind of picture it. If we can't picture it, we'll draw a little picture. So we have a little truck. That looks like a little horse, but put another wheel here. Now, maybe now it looks like a truck. It doesn't, but okay. Right, and on here we have 70 blocks stacked on it, right? And I'm obviously not going to draw 70 blocks, but there's 70 blocks. The forklift can carry a maximum of 2,500 pounds. So if I were to kind of start looking to see what's important here, I have 70 pound blocks, and I can carry a maximum of 2,500 pounds. And the pallet weighs 50 pounds by itself with no blocks on it. So we want to know how many blocks can be stacked on a pallet and lifted by the forklift. Well, I know a few things, right? So I know, first of all, that if I don't have any blocks, my pallet weighs 50 pounds. So I start with the 50 pounds. And then if I put one block on it, then I have 70 pounds, right? If I put two blocks on it, then I have 2 times 70, or 140. If I stack 3, I have 210. So what I'm going to do is multiply 70 by x, where x is equal to the number of blocks, right? I guess I didn't really need to make it a truck. I guess we just need a pallet. So we have a pallet instead of a truck. Then it doesn't look as stupid. Okay, so if I want to know how much weight, if I were to lift that pallet, if I want to know how much weight it is, well, how many blocks do I have on it? If I have 10 blocks on it, it's going to be 10 times 70, which is 700 plus 50, so 750 pounds, right? So that is how you decide how much weight is on the forklift. But the maximum it can carry is 2,500 pounds. So whatever this is has to be less than or equal. It can be equal because it can carry 2,500 pounds. If it said it can carry up to 2,500 pounds, then I would say it probably means it can't carry the 2,500. So we would, again, have a less than instead of a less than or equal. But since it can equal 2,500, we put less than or equal. Now, also, you always want to remember when you're looking to solve a word problem, we want to know what the question is. And the question is, how many blocks can we stack on the pallet? So we just want to find x, because x is the number of blocks on the pallet, right? So first thing I do, just like I would at any time, is I subtract 50 from both sides. And this gives me 2,450. And this gives me 70x is less than or equal to that. I divide both sides by 70. And I get x is less than or equal. Well, I can cancel the zeros, so I know it's 245 divided by 7. And since I don't have a calculator handy, I'll just do it. I think I can do this pretty easily over here. Divided by 7 is 321. Subtract, I get 35. And I get 5, right? Because 5 times 7 is 35. So x is less than or equal to 35. So I can stack up to 35 blocks. If I stack 36 blocks, I'm gonna break my forklift, right? So if you had, it didn't happen here and it may not ever happen on any problem that you get, but if it did happen where you had a decimal, let's say this was 34.9. I would have to round down because if I put 35 on there, it would be over 2,500 pounds if my numbers were different, right? So I have to keep it less than 2,500. So I would have to say 34 blocks. That's not the case in this problem, but if you ever have a problem where you have a number with a decimal, you let the you don't round it, because if you round up, it'll mean that that number is gonna be more than 2,500, which is no good. So we would always have to round down. Hopefully, again, that makes sense. So my answer here is 35 blocks. And then let's do our last application problem. And of course, the first thing I do is I read it and I try to draw a picture. I think I'll draw the picture up at the top. So the perimeter of a rectangular fence is to be at least 80 feet and no more than 140 feet. So I'm going to first start off by drawing a rectangle because I have a rectangular fence. And I know that the perimeter, so how would I write that? I'll say P is equal to the perimeter is so it says is to be at least 80 feet. So the perimeter has got to be greater than or equal to 80. And it can be no more than 140 feet. So that means it has to be less than or equal to 140. Okay, so the perimeter is somewhere between 80 and 140 feet. So that's what I get so far from reading the first, really all I read is the first sentence. If the width of the fence is 12 feet, and I'll call this length and I'll call this width. So I'll say width is equal to 12 feet. What is the range of values for the length of the fence? And I think this would be L, even though it looks like an I. So it's let L be the length of the rectangle as shown. The perimeter P of the rectangle is. So we're going to first figure out, well, first, how do you find the perimeter of something? I believe we already talked about this. The perimeter is if I start here and I walk around the edges, then I will have a perimeter, right? That's my perimeter. So it would be, and since both sides, like this is also 12 feet, and this is also whatever the length is. So I can say the perimeter of that rectangle is equal to 2 times 12, which are the two widths, plus 2 times L, which are the two lengths. So that equals 24 plus 2L. Okay, and we know the perimeter is between 80 and 140. So I can take this equation right here and put it in there for P. So what do I get? I get 80 is less than or equal to P, which is less than or equal to 140. But P I already know, so I'm not going to put P again. I'm going to put 24 plus 2L, and that's less than or equal to 140. And now I solve. So I'm going to subtract 24 from every part. So I get 6, 5, 56. It's less than or equal to 2L, which is less than or equal to 116. Yes, that looks right. And then I can divide everything by 2. Let me do a different color. So I'm going to divide everything by 2. I think I can do this on one. slide. Let's see. So 56 divided by 2 is 28, is less than or equal to L, which is less than or equal to 58, which means that the length of my rectangle has got to be between 28 feet and 58 feet. And this is feet. Let me just write it next to it here. So let's see if we answered the question. Let L be the length of the rectangle as shown. The perimeter P of the rectangle is. So did we answer it? Actually, I don't think we answered this question yet. Oh, here it is. We did. What is the range? Here's the question. What is the range of values for the length of the fence? This is the part underneath it is not really the end of like, that's not the question. The question is, what is the range of values for the length of the fence? And as you can see, I found the range of values for the length of the fence. So, and that concludes this lecture on, yes, that concludes this lecture on inequalities. Thank you for watching. And if you have any questions, please feel free to reach out anytime. You can come to my office hours, or if my office hours don't work, please make sure you just email me and tell me what works for you, and we'll set up an appointment. All right, have a good day. Thank you.